Yeah, hi. Welcome everybody. In the last video, we spoke about uh, how to write the Verilog. We did a video on it. So today, right now, we're gonna see how we can actually simulate and test the system Verilog with model sim system Verilog. So let's have a look. Those who have seen the previous video, it's continued from there.
In the last video, we wrote a finite state machine, this thing, to implement this. Now, let's simulate it. You want something to actually make sure that this is doing the right thing. So let's go right-click, add to project, new file. We're going to call this example fsm_tb for test bench.
So you can name it anything, but it's better you keep the same names, whatever is being told. So if you have that thing in there, it is in your it has been stored, so you have to extract it, get it here, and then start simulation and tests.
And it's going to be a system Verilog file. And so the first thing we're going to do here is we're going to set the time scale.
So time scale, setting this up is very important. Look how we do it.
Scale is going to be 1 nanosecond over 1 nanosecond. What that means is that, when we're feeding inputs to this thing, we're going to want delays, right? So we're going to give it a clock, one of the inputs that we've defined here. And we just need a certain time.
So I'm going to leave this to you. It says it's a kind of a delay of few nanoseconds. And this is because of some purpose. We do it intentionally with some time delay.
Period to set the frequency for that. Then we're just going to create a module called example fsm_tb. So we're going to create a few variables that are the inputs and outputs of the FSM. So the first one is just going to be clock. The other one is just going to be reset. And then for the input, which we've called x here.
So clock and reset. And the third one is going to be?
We're just going to call that in. So I'm just going to call this logic in, and that's going to be what we're feeding into the FSM. And then we're going to have another variable called logic out, and that's just going to be the variable that contains the output of the FSM. What this is actually when we wire it together. So we say example FSM, and then you say DUT. That just stands for device under test. And then now we're saying, okay, the clock wire of the FSM, we're going to feed that with our variable clock. The reset wire, we're going to feed that with our variable reset.
So variable clock and variable reset. Points to be noted. Initially, we did the clock and the reset, and now variable clock and variable reset.
X variable, we're going to feed that with our variable in, and then the Y is fed with our variable out. Then we close that off, and yeah, this is, this right here is...
See the highlighted things.
The wiring connecting these two things together. And we're going to say end module here, and just going to compile it, make sure everything's working.
So once you're done, then you do the compilation and see if it's working.
Okay, and we're going to have two categories. One's going to be always, and we're going to say begin and end. So first we're going to say our clock goes high, and then our clock goes low. And that'll keep...
So two states for the clock, high and low.
Keep going, but we need to, give it some delay here. So we're going to say wait for 5 nanoseconds, and then go low and wait for 5 nanoseconds again. And so our full period is going to be 10 nanoseconds.
So right now, what he did is he put some delay for 5 nanoseconds for each. So total is like 10 nanoseconds.
So that's what's going to be going on always. But then we're also going to have a thing called initial. And this is only going to happen once, but it's going to happen sequentially. And this is where we're going to feed it in our values. So the first value we're going to feed in is reset. We're going to say that should be 1, which means we're just going to stay here. And we'll say wait a period. So wait 10 nanoseconds. And then we're going to set reset equal to 0. And we're going to set the in equal to 0. And we're going to wait 10 nanoseconds. What that should do is it should go, okay, reset's off, we can start to move. In is 0. Hey, next cycle, we're gonna go to B here, right?
So we finished the A, and now in next cycle we're gonna go for the B.
And so we can start to give it some more values here. We can say, all right, what else is gonna happen? Now let's simulate it, all right? So just go simulate, go to view, and then go library. And
so
you see this
from the top menu, you click view and then the library, and you see this.
Work folder here, you want to expand that out and you'll see your test bench. And you want to go right click on the test bench, not on the FSM.
So this is very important. You have to click on the test bench, not on the FSM. So you can write it down, the important points.
Go simulate without optimization.
Because at the moment we don't need an optimization, so we're just doing the simulation without optimization.
And that'll do some fancy stuff. It'll bring up some stuff you haven't seen before. And then you go right click here in this objects pane, right click, add to, wave, signals and region. And that'll create this wave thing.
So now,
now if we go back to our
we created the wave thing here.
Model sim, we go simulate, run 100. Let's go back to our wave, and hey, look at that, it's doing a thing. Okay, so now zoom in.
So if you after the simulation, you see how this wave thing comes up.
On that, you can see, hey, it ran for 100 nanoseconds, and you can see first resets high. And it's like, oh yeah, first resets high. Also, first thing we didn't really specify.
So you will see what you selected in the beginning, like the first of them, there you see the logic ones, higher ones here in the beginning. So it is being shown for 10 nanoseconds for now.
It didn't be, so it's red. Next cycle, we say, okay, resets low, ins low. Boom, it's low. Next cycle, we say ins high. So ins high for the next 3 cycles.
So whatever you did, it's going to show it here, high or low, and you can just verify with what you typed here.
Cycle, cycle, cycle. Then ends low. In goes low again. And you can look at the input here, right? So what happens? Let's trace it. And this is kind of painstaking to do, which is why I left those spaces. But what happens is resets high, so we're here, okay? Then we set reset low. So it goes, okay, what am I doing next cycle? The input is low, it's 0. So next cycle, I'm going to B. And so it says, okay, I'm still outputting 0 at this cycle. And now we're here, and the input is now gone high, so it goes, okay, next cycle, I'm going to 1. So it goes, awesome. Then boom, next cycle, gets to 1. The output changes from 0 to 1. And it's outputting 1. Input is high, so it goes, okay. So while it's here, it's saying, all right, what am I doing next cycle? Well, my input's 1.
Now, next cycle, which one? After A and B, what is the next cycle? Either D, C, or E? Let's see.
That means I should go to C. So then boom, hit.
Yeah, so in next cycle, it's going to go to C. So we'll talk about C.
Next cycle, hit C, open a 0 again. But that's kind of painful, so I'm just going to stop this. And in our test bench, we're going to include that. We're going to check for that in the test bench itself, so we don't have to like go in and look to see if it's making sure everything is happening exactly how we want it to happen.
So remember, you have to go to the test bench.
So beforehand, we go, all right, here, we know that the output should be 0. So we're going to go assert that the output equals 0. And if it doesn't, throw an error saying big problem at 0. Okay.
So if it's 0, fine. If it's not, then there's an issue.
Okay, so I added some more inputs to walk through some more states, and I added some more asserts. So now, if we rebuild everything, we go compile all, and we go to library, again, right-click, simulate without optimization, right-click, add to, wave, signals and region.
Add to wave, signals, and region. Remember this sequence.
There's your wave, simulate, run 100.
So when you see wave, simulate, and then run.
But you can see, in our output, we had an error. Big problem at 6 times 70 nanoseconds. So we go, hey, what was happening here? So we go to our finite state machine, test bench, and we look at number 6. So hey, 6, it was supposed to be 0.
So if there is an error, it's going to tell you where it is at number 6 in this case. So something went wrong there. So just go to that particular point.
And what was it? Well, we can look at this. We can say, okay, this happened in 70 nanoseconds. I mean, you and me, we know, hey, well, if it was wrong, it was just 1. But you might have a vector or integers or something more complicated. And so, but let me just update this here. We go, big problem at 6. We'd say, okay, that should be a 1 then. And now we can just go compile all, simulate, and then you just go restart, yes to all that stuff, simulate, run your 100, and then go back to our wave. Well, first of all, I mean, I could just see the error is not there anymore.
So you see how that error has been rectified.
So I mean, I don't even really need to look at the wave, but there's our wave anyway, and isn't that great? Well, no, not really, because I mean, look at this code. This is atrocious. The last thing you want to be doing is copying and pasting the exact same line, having to increment this from 0, 1, 2, 3. I mean, even for a FSM, this...
See the highlighted code that you have? So in every time you have to just copy and keep doing it by changing the things, right?
Big. You don't want to be doing it like this. What you want to be doing is what I'm going to show you in the next video, which is creating a test vector that you can just feed into the FSM, and it'll output at exactly what inputs were wrong.
So we are done till here. So now you can try in the lab. So for the next video, then we're gonna tell you some more things. This is how we do the simulation and test in the Verilog. Thank you.